Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on triangles. So what is a triangle? A triangle is any three-sided shape like this. That's where it gets its name from. Three sides means it has three angles. Tri means three. Triangle equals three angles. So I just want you to note something like this is not a triangle because that curved length there is technically not a side. That shape technically doesn't have three sides. So I know you know what a triangle looks like. In this video, we are going to look specifically at classifying different types of triangles and calculating unknown angles. So let's start by looking at unknown angles inside a triangle. So for a triangle like this, in fact for any triangle at all, what you can do is you can look at this point here called the apex of the triangle. I can draw a line through that is parallel to the base of the triangle. So let's call this angle here X, this angle here Y, and this angle here Z. So because these three angles make up a straight line, they are supplementary. Now, I don't know what X equals, what Y equals, or what Z equals, but what I do know is that when I add all of them together, I get 180 degrees because they're supplementary. But hang on a minute, this angle here I can call X. These two angles, this one and this one, are equal because they are alternate. Similarly, I can call this angle here Z. This angle and this angle are equal because they are alternate. So where I've used the same pronumeral, that means the angles are equal. So I have that X plus Y plus Z equals 180. I've just explained why the three angles inside a triangle add up to 180 degrees. This explanation works for any triangle. Doesn't matter how wonky it looks, it doesn't matter what type of triangle it is. The three angles inside a triangle always add up to 180 degrees. So don't worry so much if you didn't quite understand why they add up to 180. If you're one of those people, just remember that the three angles inside a triangle add to 180. And we can use this to find unknown angles. Let's look at a few examples of this. So let's look at this black triangle down the bottom. We want to find the value of X. Well, it turns out this is really easy because I know that X plus this angle here, 43, plus this angle here add to 180. So this angle here is 90 degrees. That's what this little symbol means. It's a right angle. So if I add all these three angles up, I get 180. Now 43 plus 90 is just 133. So what I'm saying is these two angles add to 133. You just have to think, how much more do I need to go from 133 to 180? If you don't know what that is off the top of your head, just go 180 minus 133 and you get 47 degrees. So X must be 47 degrees because these three angles must add to 180. So let's look at another example. So let's now look at the green triangle and figure out what Z equals. So just so you know, if you have this arc here mean those two angles are equal. So if this one is 20 degrees, this one must also be 20 degrees. So we have that Z plus this angle plus this angle, they must add to 180 degrees because the angles inside any triangle add to 180 degrees. So of course 20 plus 20 is just 40. So we're saying how much more do we need to go from 40 to 180? And you can just do Z equals 180 minus 40, which is 140 degrees. And we're done. Let's look at an example now that's slightly harder. So we now look at the red triangle. This one's a little harder because there are actually two angles we don't know the value of, this one and this one. But we can still figure out what they equal because we know that those two plus this one must add to 180. So we have Y plus the 38 degree angle must equal 180. So we know from algebra y plus y is 2y. So when I add 2 lots of this angle to 38, I must get 180. So 180 minus 38 is 142. So what I'm saying is this angle plus this angle must add up to 142, so that the angle sum of this triangle is 180. So what we're saying is which number, when you add it to itself, gives you 142. Or in other words, which number, when you double it, times by 2 gives 142. So you can figure that out by doing the opposite of timesing by 2 and dividing by 2. So y is just 142 divided by 2, which is 71. So each of these angles here must equal 71, so that all the angles add to 71 plus 38, which is 180. So we're now going to turn our attention to exterior angles of a triangle. Please pause and copy down these examples if you need. So we look at exterior angles of a triangle. Exterior means outside in this context. We're looking at angles outside the triangle. So what do I mean by that? Well, let's just draw a normal triangle. Now, if I keep this side going like this, I have an exterior angle. This angle here that I'm coloring in red is called an exterior angle of the triangle. Now, I know that this red angle plus the angle I'm coloring in black, both of those angles must add up to 180. They are supplementary. They make a straight line. So that's pretty clear. But if I now look at the other angles inside this triangle, I'm going to color one green and I'm going to color the other yellow. I know that all 3 angles inside this triangle must add to 180. So I know that black plus green plus yellow must equal 180 because the angle sum of any triangle is 180. So if I have these equations here, I can sort of cross out the blacks and the 180. What I'm saying is that the only way that these equations can be true is if this one here is equal to those two. The red angle must be equal to the green angle and the yellow angle put together, because for both of these circles, when you add them to the black, you get 180. So they have to be equal. So the red angle must be equal to the green angle plus the yellow angle. So what we're saying is the exterior angle is equal to the 2 angles inside the triangle that are opposite. So what I've said in red is just a more formal way of putting it. This is the rule you need to know. The exterior angle of a triangle is equal to the 2 opposite, so facing, those 2 interior angles, the 2 opposite interior angles. Remember, interior means inside the triangle, exterior outside the triangle. So once again, we can use this to find some unknown angles. Let's look at some examples. So let's look at x in the black triangle here. X is an exterior angle, so it's equal to the sum of the 2 opposite interior angles. So in this diagram, x is just 40 plus 50, which is 90 degrees. So note, just like on the previous slide, we found the unknown angle without measuring it. All right, let's look at another example. So let's look at this example in green. This one's slightly different. In the last one, we were finding the exterior angle. Now we're told the exterior angle, and we're going to use it to find one of the interior angles. So I know that this one plus this one equals this one. The exterior angle 123 is equal to the sum of the 2 opposite interior angles. So you just have to say, what do I need to add to 70 to get 123? So in this case, y is 123 minus 70, which gives you 53 degrees. How easy is that? All right, we're now going to go on to classifying triangles. Please pause and copy this down if you need. So we're now going to look at classifying different types of triangles. So just note, we're going to be talking about angles first up. So it's important that you recall acute angles are less than 90 degrees, right angles are equal to 90 degrees, and obtuse angles are more than 90 but less than 180. So we said earlier that the angles inside any triangle add up to 180 degrees. If we think about it, we can't have a triangle that has more than one obtuse angle or more than one right angle. I mean, let's try and draw a triangle with two right angles. It'd have like one here and one here. But this line here and this line here would never meet. They're parallel. Similarly, if we try and draw a triangle with more than one obtuse angle, well, if we draw one like this, that's an obtuse angle. But if I draw another obtuse angle, it's going to go over there. The lines are getting further and further apart. So what I'm saying to you, a triangle can only have one obtuse angle, one right angle, or if it has neither of those, then all three angles must be acute. You can't have a triangle that has more than one obtuse angle or more than one right angle. So that's the first way we're going to classify triangles. They're going to be one and only one of these. Either they have one obtuse angle, in which case they're obtuse angled, one right angle, in which case they're right angle, or they have all acute angles, in which case they're acute angled. So each triangle will be one and only one of these. It will either be obtuse angled, right angled, or acute angled. But that doesn't tell the whole story. There are other ways we want to classify triangles. What about the number of equal sides they have? So we also classify triangles according to how many equal sides they have. So the note down the bottom, the number of equal sides equals the number of equal angles. So what that means is if a triangle has no equal sides, then no two of its angles will be equal. If it has two equal sides, then two of its angles will be equal to each other. And if all of its sides are equal, then all of its angles will be equal. So we have special names for classifying sides. So if it has no equal sides, it's called a scalene triangle. Note the spelling, please. If it has two equal sides, it's called isosceles. Once again, note the spelling. And if it has all equal sides, it's called equilateral. So each triangle can be classified according to both an angle name and a side name. So let's look at some examples. So what I want you to note is that these little dashes indicate equal. So two dashes here and two dashes there mean these two sides are equal. Similarly, this dash and this dash mean those two sides are equal. So these two triangles in red are both isosceles triangles because they have two equal sides. Look at the top one. Note that a right angle would be like this. That's what a right angle look like. So what I'm saying is this angle here is more than 90 degrees. It is an obtuse angle. So the top triangle is actually an obtuse angled isosceles. If we look, however, at the bottom triangle, all its angles would be less than 90 degrees. You know, if we had a protractor here, a right angle would be like this. This angle is less than 90 degrees. Similarly, this one and this one, they're all less than 90 degrees. So this, it turns out, would be an acute angled isosceles. Now, for isosceles triangles, because they have two equal sides, they also have two equal angles. So the two angles that are equal are always the base angles. They're always the two angles where the equal sides meet the third one. So what I'm saying is in this triangle, this angle and this angle will be equal, and this third one different. In the other one, it's this angle here and this angle here, marking them both with an X to indicate they're equal. Those two angles marked with an X are equal. It's always the base angles that are equal. So let's say we had a triangle like this. So I'll say that that angle there is 40 degrees and this angle is 50 degrees. So what type of triangle would this be? So if you're asked the type of triangle, you need to give an angle name and a side name. So clearly this has a right angle, so it's a right-angled triangle. Now, because none of the angles are equal, none of the sides will be equal. So this is a right-angled scalene triangle. And how easy is that? Classifying triangles is very easy. I'm just going to rub out the three examples on the right-hand side so we can do a slightly more complicated example. So let's look at this black triangle here, and we're now going to classify it. So it looks similar to the triangle that we just saw. But what we need to do is first figure out the unknown angle. Now, we know that this is going to be a right-angled triangle, but we don't know whether it's scalene or isosceles until we find the third angle. So this angle here would be 180 minus 90 minus 45. It would also be 45 degrees. So this triangle actually is right-angled, but there are two equal angles, which means it will have two equal sides. It means that this side and this side will be equal, and so this is a right-angled isosceles triangle. So the very last thing I want to say is that if we have an isosceles or scalene triangle, they can be obtuse-angled, right-angled, or acute-angled. But it turns out if you have an equilateral triangle, it can't be obtuse-angled or right-angled. So if we have an equilateral triangle, it means it has all sides equal, but it also has all its angles equal. Now, because all three of these angles are equal and must add up to 180 degrees, each of these will be 60 degrees. Each angle inside an equilateral triangle is equal to 60 degrees. So all equilateral triangles are acute angled. All right, sorry for the long video. There's 3 people from my class who say the words caramello koala and reference this video. You can have a caramello koala for making it through. This has been the luckiest maths teacher in the world. Thank you so much for tuning in and have a great day.